Now, when finding the sample variance and sample standard deviation, so now we're using sample data, not population data. We have very similar calculations, but there's one slight change. Instead of dividing by n, the total number of data, we divide by n minus 1. And the reason we make this change is because over time, we have actually seen that using n minus 1 with sample data better approximates the population variance and the population standard deviation. So it's using n minus 1 with our sample data gives us a better approximation to the population values instead. So I know that seems kind of weird to think that way, but a lot of research and studies have been shown on this, and it gives us a better answer. So when you're doing variance or standard deviation with sample data, then you're just going to divide by n minus 1 instead. Otherwise, everything else is the same. So you just want to be really careful with that change because you do get different answers. So if you're not sure what kind of data you have, you could get the wrong answer, right? So population data uses one formula, sample data uses a different formula here. So again, you have the same issues when you square your data, you end up having the units get squared as well. So if we take the square root at the end, then our units make much more sense. They relate to our exact data. So that's why a lot of times you'll see the standard deviation being used instead of the variance here. So let's do another example by hand. And I kind of didn't leave myself room on my handout at home, so I'm gonna give myself a little bit more room here. Extend my paper. All right, so find the sample standard deviation and variance of the following data. So this is recovery times in days for high school football players that suffered a concussion. And we're told that this is sample data. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Just make a note, I have 12 data points here. I'm going to start the same way. The first thing I have to do is I have to find the mean. So my mean here would be X bar. My population mean, remember, was mu. So you're seeing those changes as well in the formulas. So instead of using mu there, because that's the population mean, we're using X bar. That's the sample mean. Right. So I'm going to take my data. So I'm going to take all that, I'm going to add it all up. And let's see, what we get is 90. Divide that by 12, and we get 7.5. Okay. Okay. So we end up getting exactly 7.5 here. So that's going to be my mean. Now, the next thing I'm going to do is I'm going to go ahead and make a table. So I'm just following the same steps as before. So I'm going to do X minus X bar here. So I have, my first data point is 4, so I do 4 minus 7.5. Then I do 7 minus 7.5, 6 minus 7.5, 7 minus 7.5, 9 minus 7.5, 5 minus 7.5, 8 minus 7.5, 10 minus 7.5, 9 again, 8 again, 7, and 10. All right, so let's do those subtractions. Okay, so for the first one here, I have negative 3.5, negative 0.5, negative 1.5, negative 0.5. Here we have 1.5. Here we have negative 2.5, 0.5, 2.5, 1.5, 0.5, negative 0.5, and then 2.5. So I do all that subtraction first. Then I'm going to take those values and I'm going to go ahead and square them. So I'm going to take that negative 3.5 and square it, negative 0.5 and square it, negative 1.5 and square it, and all the way down the line. And again, your signs don't really matter so much here because once we square it, the negatives and positives will all become positive anyway. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Just making sure I have all my values. You can see this gets really tedious. It's really easy to make a mistake too, right? Just typing in a little number wrong or being just a little off in a calculation. So let's see, 3.5 squared gives me 12.25. 0.25. I'm just filling all the same values of this at once. Get a little bit faster here. So once that's done, I'm going to go ahead, I'm going to add these all up. Remember, this is called my sum of squares. And when I go ahead and add those all up, I get 39 here. Okay. So my second step is to just take my time, make that table. You don't have to write the sum on the side. You can write underneath too. I'm just kind of running out of room here. So I'm going to go ahead and add those all up. So now I'm ready to actually calculate. I just tend to like to do my variance first. Even if the question asks for my standard deviation first, I usually just do them both together. I like to do my variance first here. Now notice the change in notation. Instead of using sigma, we're using the regular English letter S for population variance, so S squared and S here. So notice the change in notation. That's really important. Sample data tends to use English letters, okay? And we mentioned before that population data uses Greek letters. So we're changing that notation here as well. So the variance here is S squared. That would be the notation we're using. So we take that total there, this that we got, 39, and we divide by n minus 1. So in this example here, our n was 12. We had 12 data points. So we're dividing that by 11 here. And again, I'm going to go ahead and just round to one decimal place, and I get about 3.5. Now remember with variance, the units don't match. So this is about 3.5 square head injuries. It's kind of weird. So what we can do is take the square root. The notation for standard deviation is just S. So you end up doing the square root of that sum of squares over n minus 1. So the square root of 39 over 11. Now, I do recommend going back to the fraction. So I know we rounded here. You could do the square root of 3.5. It's going to usually be the same. But in case there's a little bit of rounding error, I would probably just go back and just use that original fraction when I type it into my calculator like that. And I get about 1.9 here. So you can see if you just typed in 3.5, again, you get 1.9 if you're rounding. But if you're using two decimal places, you'd be off, right? So it's better to go back to the original fraction and use that square root than to try to do it after you've already rounded. So always save your rounding steps to the end, even here for the standard deviation. So now the standard deviation refers to 1.9. And if you go back to your data, this was about concussions, right? So about 1.9 concussions. So our units make a little bit more sense here than 3.5 concussions squared. So you do see the standard deviation tends to get used a lot more than the variance when we're working with data.